All right, you guys, final review day one. So Friday there will be a quiz. So make sure you are studying. Number one is A. So really this is just the definition of confidence level, or the sentence you need to know for confidence level, which is always in repeated random samples of the same size. 95% will contain the true mean. This one says the sampled mean. Every single one of them contains the sampled mean, but only 95% of them contain the true mean. So it is A. Okay, number two, I was trying to do binomial CDF and then I realized that it does not meet bins. So in order to use binomial CDF, it has to be binomial. So it is binary, however, it is not independent. The problem is that we don't know what's in the jury pool. So 30% of the pool are women, but what if the pool is only 15 women? And as soon as you pick one, then the percent of women changes. So not only is it not independent, but this probability of success changes every time that you draw someone. It's no longer 30%. All right, so it is E. Number three, we just do norm CDF. Your lower bound is 3,000 because that's when we're going to run out. Up to a big number, probably should have put like 10,000. Mean is 2,500, standard deviation is 225, and you get D. Number four, so 1 in 5 have side effects. We want them to not have side effects, all 4 of them. And so that's 4/5 to the 4th power, which is B. All right, number 5, if you're thinking tree diagram, don't do it because it's not saying if they request tires, then what's the probability of an oil change or something like that. Remember, tree diagrams are conditional, and these are not telling us conditional probabilities. We just know the probability that they get an oil change is 60%, the probability they buy tires is 30%, and the probability of both of those happening is 10%. The best way to display this would be a Venn diagram. So we have 10% in the middle. And then this one's my oil change, which has to add to 60. So I put a 50% here. And this one is the tires, which has to be a total of 30%. So that's why we put 20% here. These three add up to 80%. So we have 20% on the outside. All right. So then it says a customer requests an oil change. What's the probability they do not request tire replacements? So this is the given part. If you guys remember, when you do these given statements, that's what this stands for, given. This is what you're finding the probability of. So not buying tires, given that they got an oil change. So the formula is on your yellow sheet. What's the probability of no tires and an oil change divided by the probability of an oil change? So this part here, you want to look at your Venn diagram. No tires. So I want to be outside of the tires circle, but I do want to be inside the oil change circle. So that's the 50% that I just covered over. All right, divided by the probability of an oil change, which is this entire thing, so 60%, gives us D. All right, number 6, this box plot. So we do know that it is skewed right, which pulls the mean up towards all these high outliers. And so also remember that like 25% of the data falls within the low or the min and Q1, and then Q1 and Q2 and Q2 and Q3, and Q3 and the max is always 25% of the data. So the answer is B. There's actually more books priced below the mean than above the mean because that mean is pulled up. Maybe it's like here because of that skew. There's a lot more books below the mean. So this one is B. Number 7. So in order to find IQR, interquartile range, we do Q3 minus Q1, and you have to know that for the test. And so then we can find Q3 because it's at the 75th percentile. They told us it was normally distributed. So just do inverse norm, area 0.75. Here's your mean, your standard deviation, which is 27.7. Do the same thing for Q1, which is at the 25th percentile, and then subtract, and you get B. All right, number 8. So for this one, it should be C. Part A says basically there's 6 treatments. The only treatment is paint. you're not assigning them a gender. And so on this one, you're just separating them by gender. Paint is definitely not a blocking factor. That's a treatment. Sex is the blocking factor. For the completely randomized design, that would mean there was no blocking. Matched pairs would mean they designated a pair, like a boy and a girl together, and they did not talk about that. So it is C. All right, so number 9. Hopefully you guys got this one. It is B. City B gets more rain on average because it's over here versus its mean being over here for city A. But it has a smaller range of annual rainfall because this guy, his range is more from here to here, so that's a smaller range than city A, where the range is from here to here. All right, number 10 is B. And so if it says regardless of the population, so if we don't know the population's normal, then we have to have large counts, which is n is greater than or equal to 30 for means. They didn't specify that, but that's okay. We just have to have a large sample. So discrete just means there's spaces in between. You can't use like decimals or continuing decimals. So A is the only one that's discrete because you're only going to guess 1 time or 2 times or 3 times or 4 times on a test. You're not going to guess 1.5 times or 2.5 times, but all the other ones can have the in-between, and so they are continuous. Number 12, you guys, you have to know this formula for margin of error. And so if I want a 90% confidence interval, by the way, I have seen this question on every test or one like it, so make sure you know the margin of error formulas. For 90%, we're going to do inverse norm. And the area that you want to plug in, if you're doing 90%, is 10% divided by 2, so 5%. Mean of 0, standard deviation of 1 gives you 1.645. They did not give us a sample P, so you use 0.5, and then our sample size is 300. So we're actually looking for the margin of error. A lot of times they're giving us the margin of error and we're solving for n, but this one we wanted the margin of error. So then we just plug this part into our calculator and we get B. By the way, if you were going to do means, remember, you would think it would be T star times S sub x over the square root of n less than or equal to your margin of error. However, if you're trying to find n, you don't know your degrees of freedom, and so you have to use Z star, which means you have to know your population standard deviation. This formula is not on the exam, and I've seen it a few times, so you might want to make sure you know that one as well for means. All right, number 13 is E. So remember, the normal distribution has less area in the tails. The T distribution has more area in the tails, which means there's a larger spread because there's more points further away from the mean. So the answer is E. K14 is A. It would be a one-tailed t-test on a population mean. So we just want to know, did it decrease from 4.8? So they didn't talk about it doing a difference. This one has something about ordered pairs. We didn't do any ordered pairs. This one's a z-test for population proportion. We're definitely not doing proportions on this problem. We are doing means. And chi-squared is categorical data, so this is definitely not a chi-square test. Number 15. So remember, you are allowed to just add the means. So you add the two means together and you get 74. However, you're not allowed to just add standard deviations. In order to add standard deviations, you have to add their variances and take the square root. So it's the square root of 3 squared plus 6 squared, which gives you D. All right, for the free response problem, so remember when you're finding the mean of a table like this, you do the data point times its probability, plus the data point times its probability, plus this one times this one, plus this one times this one, and you should get a mean of 2.6 hours. All right, for this table, first you fill in the cost. So it says X is the parking fee charged. So I want to first fill in my parking fee. Well, for 1 hour, it's $3. And then you add $2.50 for the next hour, and you add $2.50 for the next hour, and you add $2.50 for the next hour. The probabilities stay the same as up top. So now we want the mean and standard deviation. So same thing for the mean, this times this, plus this times this, plus this times this, plus this times this. So our average cost is $7. Standard deviation formula, you guys probably haven't seen this in a while. So it's the square root of the data point, so that would be the first data point of 3, minus the mean squared times its probability, plus the next data point minus the mean squared times its probability. Okay, all the way through. In case you guys forgot, you can do this on your calculator. So if you enter the data and you do just, that's the fee, and this one's the probability, you go to Menu, Statistics, Stat Calculations, One Variable Statistics, and you plug in your X list as fee and your frequency list as probability. So it's still a one variable statistics, but you're putting probability in for frequency that we usually don't do. All right, still gives you a mean of 7. Notice you don't get S sub X. You don't use that. Because you have all the data, this is the population standard deviation, and it's okay to use that on this problem. All right, so for the next one, it says that he usually parks for 1 hour or less. That's 80% of the time that he does that. So for 80% of the time, he's going to be charged $3 because that's 1 hour or less. So the rest of the time, he never parks for over 2 hours. So that means from 1 to 2 hours, he's being charged $5.50, and that only happens 20% of the time. So his average cost is $3.50 per day. So should he buy a parking permit, or what's that breaking point for the parking permit? So I want to be, if he wants to be under $100, we can just divide 100 by 350, and that means he needs to park there 28 days of the month or less. But once he goes to 29, then it's better to just buy the permit. All right, so the minimum is 29 times in order for the monthly permit to cost less than his expected cost at the hourly rate. All right, that's it.